We now want to start talking about systems of linear equations. A system of linear equations is any set of two or more linear equations that we consider together at the same time. Here's an example of a system of linear equations in two variables. The first equation is 2x plus 3y equals 5. The second equation is 3x minus y equals 13. We want to consider these together. Now, normally when we talk about equations, our primary goal is going to be to solve them. So what about when we talk about a system of equations? We want to solve the system. That means that we want to solve both equations at once. So what does it mean to solve a system? Well, remember that to solve an equation in two variables, we need to have a value for both variables, x and y in this case. An example, 1, 1. In other words, the point when x equals 1 and y equals 1. That is a solution to this first equation, because if we substitute those values for x and y, then we get a true statement. We get 2 plus 3 equals 5. On the other hand, if we substitute those values into our second equation, then what's going to happen? We're going to get the statement 3 minus 1 equals 13, which is not a true statement. So that shows that 1, 1 is a solution of the first equation, but not a solution of the second equation. So what is it going to mean for us to find a solution of the system? A solution to a system is going to be a solution to both equations simultaneously. We saw that the point 1, 1 is a solution of the first equation, but not of the second equation. That will not be a solution of the system because it doesn't solve both equations at the same time. A different example, the point 4, negative 1. Let's try that. If we substitute 4 in for x and negative 1 in for y, then what we end up with is the statement that 8 minus 3 equals 5. That's a true statement. For the second equation, if we substitute in 4, negative 1 for x and y, we get the statement 12 plus 1 equals 13. Also a true statement, which means 4, negative 1 is a solution to the first equation and a solution to the second equation. Therefore, it is a solution to the system. So how can we find the solution to a system? We just sort of pulled this out of the air. There are three basic methods that we will talk about for how to solve a system of equations. We can solve a system graphically, we can solve it by substitution, or we can solve it by elimination. The last two methods will be algebraic methods. Let's talk about graphing first. To solve a system of equations by graphing, we're going to do what you would expect and graph each of the equations. You can do this with paper and pencil, but you have to draw a very accurate graph. And even then, if your answer is not a really nice answer, it can be difficult to determine what it is. It's better to use a graphing calculator when solving a system by graphing. Notice that in this system, I've set it up so that we have two equations in slope-intercept form, y equals mx plus b. That's because that's the format we need to use for the calculator. Let's turn our calculator on. We're going to press the y equals button so that we can input our two equations. We'll input 2x plus 12 for the first one, and negative 4x minus 3 for the second. And then we want the calculator to graph these for us. There's our first equation, 2x or y equals 2x plus 12. There's our second equation, y equals negative 4x minus 3. Now that it's graphed lines that represent the equations, how does that help us find the solution? Well, the key to remember here is every point on the line represents a solution to the equation. So, see, I'm scrolling along on this line, and as I do, it changes my x and y values. Each of those pairs of x and y values represent a solution to our first equation, y equals 2x plus 12. If I press up and skip over to my other equation, see, now I'm on the other equation. Each one of these points represents a solution to our second equation. So where will we find a solution to both equations at once? Precisely at the intersection point. Now the values listed here do not represent the intersection. They are just in the ballpark. We can get the calculator to actually figure out the intersection for us. It's in the Calculate menu. So to access that, we have to press the second button, and then the Trace button. Then we'll access the Calculate menu. In the Calculate menu, we see option 5 is the intersect. Select that. It'll ask us for the first curve. See how the cursor is on one of our lines. All you need to do is press Enter. Now our cursor is on the other line, and it says second curve. So we press Enter again. That tells the calculator that those are the two lines that it wants, or that we want to find the intersection point of. It asks for a guess. If you want to, you can get close, but you don't necessarily need to. The calculator can figure it out without the guess. Hit Enter one more time because this is not the answer. Notice now after we've hit Enter the third time, it says intersection, x equals negative 2.5, y equals 7. And so that is the solution to our system. Let's just verify algebraically that this solution is correct. The solution we found was negative 2.57. If we substitute those values into the first equation, then we see 7 equals 2 times negative 2.5 plus 12, which is, this ends up being a negative 5 plus 12. Negative 5 plus 12 is 7. So that confirms that it's a solution of the first equation. In the second equation, we get 7 equals negative 4 times negative 2.5 minus 3, which ends up being positive 10 minus 3. 10 minus 3 is also 7. And that confirms that it is a solution of the second equation. And since it's a solution of the first and the second equation, that makes it a solution of the system. Let's look at a second example of solving a system by graphing. Notice that this system is not set up with the equations in slope-intercept form. Therefore, we cannot put it in the calculator in this form. We're going to have to do a little work first. We'll take each equation and we have to rewrite it in slope-intercept form. In other words, solve the equation for y. So we can take our x plus 5y equals 20, subtract x from each side, we get 5y equals negative x plus 20, then divide by 5 on each side, and we end up with y equals negative 1/5 x plus 4. For our second equation, 3x minus 5y equals 0. we will subtract the 3x from each side, and then divide by -5 on each side, and we'll get that y is equal to a positive 3/5 x. Now these are in a form that I can use in my calculator. Returning to the calculator, we see that once we've entered these equations in, now we graph them. Here's our first equation. Here's our second equation. There's the intersection point, clearly visible, so we press second trace to get to the calculate menu. We go down to the intersect. It asks us for first curve, we hit enter. Second curve, we hit enter. That selects our two curves for us. I guess, again, that doesn't really matter, so we hit enter once more. And there's our intersection point, 5, 3. And you can verify that that is in fact a solution on your own time.